Welcome. We're now ready to take a look at some graphical displays of data, starting with what is called a histogram. And we'll get to that in a moment. Let's jump in, though, with the example. So a teacher gave an exam to her students last week. Construct a grouped frequency distribution and histogram of the data using an initial class boundary of 35.5, an ending class boundary of 50.5, and 5 classes of equal width. All right, so let's start with the data here. So these are scores for some students that took an exam. I've put the scores in numerical order for us. So the data have been sorted. So if you do get data that is not sorted, I highly encourage you to sort it using your graphing calculator. It just makes life easier as we construct our grouped frequency distribution if you've got the numbers in order. All right. So before we get to this graph called a histogram, let's create our table here, our grouped frequency distribution. And we're going to need to, it says, start with an initial class boundary of 35.5. So it's giving me my boundaries where we start. And then eventually here, I'm going to end at 50.5. And we are going to create 5 groupings called classes of equal width. And in order to do that, we're going to need to figure out the distance from one class to the next. And that's always found by adding the width. So in order to create this scenario of 5 groupings and starting and ending points, we're going to calculate the class width using this formula. So what we do is start with the ending boundary, 50.5, subtract the initial boundary of 35.5, and you divide that by the number of classes or groupings that we're trying to create. And in this case, that was 5. So the numerator there, if you subtract, will be 15 divided by 5. So we have a class width of 3. All right, so that tells me that if I add 3, giving me 38.5 is the beginning of the next class. And then once you know the class width, you can just continue to add that going down the table here. So the class width can't change. Once you have it, you need to consistently use that value. And then we'll go back in and put our upper boundaries for each of these classes. So the way boundaries work is where one class begins, that boundary will match where the previous class ended. So that will also be 38.5. So those values will always be the same. And then that process continues, or you can just, again, think of adding 3 each time, whatever's easier for you to fill in these upper boundaries. And then we always check here that we did it correctly, because when I get to the end, if I add 3, I do end up at 50.5. So we know that we've done that column correctly. And then we're going to talk about the limits. So limits are the whole number scores inside of the boundaries. In other words, students that scored between those 2 values. So I'm just going to come down to my graph for a moment just to give you the visual here. So on my x-axis, this is representing scores. So I'm just going to label that, scores on a test, on an exam. One more time, scores. And what we're going to do when we create this graph called frequency histogram is we're going to use those boundaries. So the first boundary was 35.5. And the ending boundary for that first class, that first group, was 38.5. And now I can visually see that the whole numbers, the scores between those boundaries, are values from 36 to 38. So those are the limits of the class. So the limits are the whole numbers, the data's whole numbers. So it's always nice to write the limits rather than the boundaries as we're going to go through our data. So the numbers that are whole numbers between those 2 values were 36, 37, and 38. So 36 to 38 are those 3 numbers. And then once you've got it started, you can just, again, use your class width to go down to start the next class. So in this case, we'll get 39. So notice here that these two numbers are different. So if that ends at 38 as a whole number, the next grouping would start at 39. So this creates groupings that are called mutually exclusive. So they can't share any values like the boundaries here did. So once you get it started, just keep adding your width, and that's to me, the quickest way to finish your table with the limits. So I'm just adding 3. And then we can just end and make sure that this looks good. So the whole numbers between those boundaries would be 48, 49, 50. So those 3 values. Okay, so now that we have the limits, I think it's easier to count the frequencies. So how many scores were in each of these ranges of values. So I'm just going to start circling. So 36 to 38, I just have 1 person. 39 to 41 would be 3 scores. 42 to 44 would be 5 scores. 45 to 47, we have 6. And 48 to 50, we have 5 scores. So those counts are our frequencies. So 1, 3, 5, 6, 5. And if I add, so capital sigma, if I add those frequencies, I'll get the total number of students that took this exam, and that's going to be 20. So 20 students there in the data set. So that's your grouped frequency distribution. And now we'll create the histogram. So this graph that's going to visually display that information. So what I'm going to do first is put down all my boundaries here on my x-axis. So I started it, and let me go ahead and finish it. So you'll use your boundaries on the x-axis. And we're going to create rectangles with the sides at the boundaries. So the width of the rectangle will be 3, the class width, telling us there's 3 whole numbers inside of each of these boundaries for each grouping. And then your y-axis will be the frequency, the number of students that are in each of these groupings. So we just had 1 student in that first group, 36 to 38. So there was just 1 student there. So we just draw a rectangle whose height is the frequency. And then in that second group, students from 39 to 41, in those boundaries, we had 3 students. So these rectangles, when we create a histogram, are going to touch one another. So they're going to be adjacent. There's not going to be a gap between them like in a bar graph we saw earlier. And then our next group, we had 5 students. And then we had 6. And then 5. Okay. And I'm just doing a little shading here. So that is called a frequency histogram. So it's basically a bar graph, but there's no spacing between the bars. And so using boundaries on the x-axis is what creates that histogram. And sometimes you'll see that we put the frequencies on top of the bars just for readability, optional. And the last thing we'll discuss here, well, 2 things actually. First, this thing called an axis break. So when I first started graphing, I established the y-axis starting at 0, and then I went up by 1. But on the x-axis, I'm not going to have any data below 35.5. So I really don't want to start at 0 going across, because if I started at 0, 35.5 would actually be, if you think like 1, 2, 3, 4, etc., 35.5 would be like way over here somewhere. And that would mean that we've just got a bunch of blank space here. So we just call that white space. So basically, I don't want to just have a bunch of blank space and then my graph over here. So an axis break, some notation in the graph indicates that we understand we're not going to start at 0. It allows us to start at any point that we'd like. And then we pick our scale, in this case, 1, going up by 1. Consistently going across. So that's all there is to an axis break. It just says, I don't want to start at 0. It doesn't make sense here graphically in our display. So I can put in a break and then start anywhere that I would like. And then the last thing is shape. So sometimes we're interested in looking for specific shapes that come up. And not every graph has a specific shape, but this one does. And so we're going to talk about the shape of this distribution. So essentially, visual displays are just trying to present something quickly to the reader to get a feel for the data. And in this case, if I look at the top 3 bars, I would call that shape symmetric, just kind of tracing out here. So that bar in the middle has a mirror image of 5 and 5 on either side of it. So that shape would be called symmetric. But we do have some students here that scored on the lower end. So it kind of tapers off or tails off here to the left. So I've got the majority of my data up here. And then as it tails off to the left, we call that shape skewed. So not symmetric, skewed. And the direction it's skewed is the left. So I like to think of it like a sliding board. If it was a sliding board, you'd climb up a ladder and you would slide to the left. So we call that skewed left. And I always do my very fancy artwork here. So there's my little dude sliding down the sliding board, having fun. So skewed left. And there you go. So that is a frequency distribution, and we've used it to create a frequency histogram.